Hey everyone, just a quick demo of the wireshark application, a wireshark protocol analyzer that we make extensive use of in our Training City hands-on classes. Wireshark is an open source protocol analyzer. This product is available for you to download and install on your own computer at any time. The more you explore and experiment with the capabilities that Wireshark offers, the more you build your own knowledge of data networking, and in particular TCP/IP and Ethernet. To begin, simply visit the wireshark.org website and click on the download button. You'll see versions of Wireshark for most popular operating systems. Find your version, download the application. The installation of Wireshark is generally quite straightforward. Do note that in Linux operating systems you will require root access to run Wireshark. Once you've installed the application and started, the opening screen provides you with a number of options to begin using Wireshark. Not only can you capture Ethernet frames as they come and go from your computer, you can also open and share other captured files, perhaps provided by one of your colleagues, or certainly when you come to a Training City training class, you'll be provided with a number of existing captures, along with, of course, conducting the hands-on labs yourself. Stored files are called PCAP files, or PCAP-NG files, and they can be emailed or placed on a shared server for use by you and your colleagues. Let's go ahead and see how to capture Ethernet frames as they come and go from this computer. We begin by clicking on the interface list. This shows a list of available interfaces for this computer. You'll note there's a VMware interface, but primarily there is my wired Ethernet adapter and my wireless adapter. I'm using the wired adapter right now, and you can see that packets are coming and going from the computer. Here we see the IPv6 address, or the link local IPv6 address associated with my Ethernet adapter. If I click on it, I see the IPv4 address associated with this interface. So, I'll click on my wired adapter and then start. Now we'll go visit a web page, trainingscity.com, and all of the associated hypertext transfer protocol for this web page will be captured in Wireshark. I go capture stop, and let's filter for hypertext transfer protocol. When you type in a valid display filter in Wireshark, this screen turns green. If you type in something that Wireshark doesn't recognize as a filter, the screen remains pink. We'll now click Apply. And we now have captured HTTP hypertext transfer protocol traffic that was associated with, or at least some of it was associated with, the visit that we made to the trainingscity.com website. We can also filter for DNS, domain name service. And here we see queries associated with, for example, finding the trainingscity.com name and associating it with an IP address. Let's clear out these filters. Wireshark itself has three primary components to the main screen. The first component shows you a list of all the captured Ethernet frames, in this case Ethernet, and their associated IP packets. So here, for example, was a DNS query for trainingscity.com. DNS is part of TCP/IP. It happens to use a protocol called UDP, User Datagram Protocol, which itself is transmitted over IP, Internet Protocol. And then, in this particular example, the local area network uses Ethernet. So this Ethernet frame, itself 80 bytes on the wire, contains an Ethernet header, an IP header, a UDP header, and a DNS header. In the bottom screen, we see the actual binary data displayed as hex numbers. You may know, perhaps not, that we use individual hex numbers to represent 4 bits. Every 2 hex numbers represent 8 bits, or what we call 1 byte. So here, for example, I'm highlighting 3 bytes of data. If we open the Ethernet header, we can actually see the source and destination MAC addresses associated with this particular transmission. If we click on the destination MAC, here it is displayed here. It's also shown here for us in Wireshark. This is a 6-byte or 48-bit number, which happens to be the designated size of Ethernet MAC addresses. We can open the IP header and examine all the fields in the IP header, which of course we do in many of our classes in detail. But for example, we see that there is a field called differentiated service field, which can be used for quality of service. There's a total length field telling us how long the IP packet is in bytes. There's the source and destination IP addresses. If you look closely, they're 1, 2, 3, 4 bytes each, or 32 bits. There's a time to live field, various fragmentation fields. All of these details we cover in class. This particular packet has a UDP header showing a source port and a destination port. We cover port numbers in detail in the TCP/IP hands-on workshop. This was just a quick, brief introduction to the Wireshark Protocol Analyzer, an incredibly important tool for anyone working and studying TCP/IP and TCP/IP related protocols. Thanks for watching.